Ever wondered how algebra, an abstract mathematical concept, plays a significant role in our daily life? Well, let's dive into that. Algebra, you see, is far more than just a collection of symbols and equations. It is a powerful tool that helps us navigate the world around us. Whether you're an economist predicting market trends, an engineer designing a bridge, or a computer scientist developing algorithms, algebra is pivotal to your work. It's the secret ingredient that allows us to solve practical problems and make informed decisions. From calculating your weekly groceries budget to determining the quickest route home, algebra is at play. It's not just about solving for X. It's about understanding how things work, how they relate, and how they can change. Indeed, algebra serves as the backbone of many aspects of our daily life. The roots of algebra can be traced back to the ancient civilizations of Egypt and Babylon. In the fertile lands of these antique societies, where the Nile and the Euphrates rivers flowed, a novel concept started to take root. This was a time when mathematics was not just numbers and equations, but a way of life. It was a tool used to solve practical problems, such as determining tax amounts and trade balances. They manipulated simple equations, played with geometric shapes, and even dabbled in a bit of what we now call algebra. Even back then, the Egyptians and Babylonians understood the power of abstract thinking. They realized that instead of dealing with specific numbers, it was often more efficient to use symbols that could represent any number. This was the birth of the X we all know and love, or sometimes dread. However, it was the Greeks and the Romans who gave a more formal structure to these techniques. They built on the foundations laid by the Egyptians and Babylonians, refining the methods and expanding the applications. The Greeks, with their love for logic and philosophy, brought a sense of order to the chaos. They introduced the concept of proofs and the idea that mathematical truths could be deduced logically. The Romans, on the other hand, were more practical. They applied these techniques to their vast empire's administration, employing them in taxation, construction, and commerce. They understood that mathematics, and in particular algebra, was not just an abstract concept, but a powerful tool to build and maintain an empire. But the story of algebra doesn't end with the fall of Rome. In fact, it was just the beginning. As the torch of civilization passed from the Greeks and Romans to the Islamic world, these mathematical ideas did not fade, but instead found a new home. And so, we arrive at a crucial turning point in our tale. The stage is set, the characters are in place, and the story of algebra is about to take a dramatic turn. For it was in the hands of the Islamic mathematicians that algebra evolved from a practical tool to a theoretical discipline. However, algebra as we know it today was largely developed by the Islamic mathematicians. The Islamic Golden Age, spanning the 8th to the 14th century, was a period of remarkable intellectual growth and the birthplace of modern algebra. This era was a beacon of enlightenment, where scholars from diverse backgrounds came together to share knowledge and make groundbreaking discoveries. One of the most influential figures of this time was the Persian mathematician Muhammad ibn Musa al-Khwarizmi. His immense contributions to mathematics, particularly algebra, were revolutionary. Let us delve into his life and works. Born in the late 8th century, Al-Khwarizmi was an esteemed scholar at the House of Wisdom in Baghdad, a leading intellectual center of the Islamic Golden Age. His works transcended the boundaries of his time, and his influence can still be felt in our modern mathematical world. Al-Khwarizmi's magnum opus, the compendious book on calculation by completion and balancing, is considered the foundational text of algebra. In this book, he introduced the fundamental algebraic methods of reduction and balancing. These techniques, known in Arabic as al-jabr, gave algebra its name and formed the basis of the subject as we know it today. His book didn't just introduce new methods, but it also presented algebra as an independent discipline, separate from geometry and arithmetic. Al-Khwarizmi demonstrated how to solve quadratic equations, linear equations, and other complex mathematical problems using his new algebraic approach. He also introduced the concept of X as the unknown variable, a notation still widely used today. Al-Khwarizmi's works laid the foundation for the development of algebra, and his influence extended far beyond the Islamic world. His book was translated into Latin in the 12th century and was used as a standard textbook in European universities for centuries. He not only gave the world Aljabar or algebra, but he also paved the way for future generations of mathematicians to explore and expand this fascinating field. Al-Khwarizmi's works laid the foundation for the development of algebra and were used as a standard textbook in European universities for centuries. From the Islamic Golden Age, algebra evolved over the centuries, with contributions from mathematicians around the world. As we left the Middle Ages and stepped into the Renaissance, a period of cultural, artistic, political, and economic rebirth, the world of algebra experienced its own renaissance. The advent of the printing press and the spread of knowledge led to a surge in mathematical learning. In this period, algebra underwent significant developments, particularly in Europe. One such development was the introduction of symbolic algebra. This was a major leap, as it allowed for more abstract and complex calculations. Rather than using words and phrases to describe mathematical relationships, symbolic algebra used symbols to represent numbers and operations. This transformed the way mathematicians worked and led to rapid advances in the field. Two mathematicians who played pivotal roles in this evolution were François Viet and René Descartes. Viet, a French mathematician, is often referred to as the father of modern algebra. He was the first to use letters of the alphabet to represent unknown quantities in equations, a system we still use today. He also introduced the use of the equal sign, another critical component of modern algebra. René Descartes, another Frenchman, further developed algebra by merging it with geometry. His work led to the invention of Cartesian coordinates, which are fundamental to modern algebra, geometry, and calculus. Descartes' work paved the way for the development of analytical geometry, which is the study of geometric properties and relations through algebraic equations. These advancements in algebra during the Renaissance and subsequent centuries were crucial in shaping the mathematical landscape as we know it. The introduction of symbolic algebra and the work of mathematicians like Viet and Descartes allowed for more complex mathematical exploration and problem solving. These advancements led to the complex algebraic systems we use today. Algebra, as we know it today, is a testament to the centuries of work and development by countless mathematicians, each contributing their unique insights and innovations. From its roots in the Islamic Golden Age to its evolution through the Renaissance and beyond, algebra's journey is one of constant growth and adaptation. The journey of algebra, from ancient civilizations to modern society, is a testament to human intellectual progress. As we shift our gaze to the present day, we find that algebra's influence permeates virtually every aspect of our daily lives. Take a moment to consider the technology that surrounds us. From the smartphones in our pockets to the GPS systems guiding our travels, all these rely heavily on algebraic equations. Algorithms that optimize search engines, facilitate secure online transactions, or even predict our online behavior, all have their roots in algebra. Now, let's shift our focus to the vast field of science. The laws governing our universe, be it Newton's laws of motion or Einstein's theory of relativity, are all expressed in the language of algebra. It's through algebra that we can quantify and predict natural phenomena, leading to advancements in fields as diverse as physics, chemistry, and biology. In the realm of economics, algebraic models are used to analyze and predict market trends. They help us understand the financial implications of interest rates, inflation, and investments. Without algebra, modern economics would be akin to navigating a ship without a compass. And it's not just the so-called hard sciences that benefit from algebra. Even in the world of art, algebra plays a pivotal role. It helps in the creation of digital graphics, animations, and even the music that fills our ears is often composed using algebraic algorithms. In essence, algebra is woven into the very fabric of our society, influencing and shaping the world as we know it. It's an invisible force that guides our progress, silently working behind the scenes to simplify complexities and solve the unsolvable. So the next time you find yourself working with X's and Y's, remember the rich history and profound impact of algebra on our world.